All right, welcome back to the deep dive. Today, we're getting very specific. We're going to be looking at a single piece of hardware that really is crucial for keeping huge industrial operations running.
Yep.
It's the NTI E-CT2000-SC76 split-core AC current transformer.
And right away, that name tells you almost everything. The key number in there, 2,000 amps.
2000.
Exactly.
Oh.
We are not talking about your server rack here.
Okay.
This is for monitoring massive electrical systems.
Yeah.
That capacity, that 2,000A, it just sets the stage for the entire discussion.
Okay, so let's unpack that. The first thing that jumps out at me from a practical standpoint is this split-core design. Why is that so important?
It's all about avoiding downtime. I mean, think about it. With a traditional solid-core transformer,
You'd have to shut off the power.
you'd have to shut everything down. You'd have to disconnect this huge, heavy primary cable and thread it through a solid ring. It's a major operation.
But with this, the top just pops open.
Right. It just snaps closed around the existing conductor. It's a game changer for installation on, live or pre-existing systems.
You're saving potentially hundreds of thousands of dollars in lost production right there.
Easily. And you can see it in the physical design. That window size, it's big because it has to be. It's made to fit around conductors that can be as thick as your arm.
Okay, so installation is simple, non-invasive. Let's talk about the data. It's measuring this huge 2,000 amp current, but the output is 333 millivolts.
Uh-huh.
That seems incredibly small. What's the logic there?
It's standardization. That 333 milliV output is, well, it's essentially the global standard for industrial sensors like this.
So it just talks to everything.
It talks to almost any SCADA system, any data logger, any controller right out of the box. It steps that huge, dangerous current down to a clean, safe, and most importantly, universal signal. It makes integration almost effortless.
And speaking of clean signals, the accuracy is listed as plus or minus 1%. And this kind of heavy industrial world, is 1% considered, good enough? Or is it exceptional?
It's highly reliable. When you factor in all the electrical noise and interference in a factory setting, holding a verified 1% accuracy is a sign of really solid engineering.
Oh?
But accuracy is only half of it. The other, and I would argue more important half, is safety.
Which brings us to the spec you highlighted, the 3 kV galvanic isolation.
Yes, this is absolutely non-negotiable.
So break that down. What is galvanic isolation doing for us?
It's an electrical firewall. You have this sensor sitting on a line with immense power. There's always a risk that a surge or a fault could cross over from that high power side to the low power monitoring side.
And fry all your expensive monitoring gear.
Or worse, injure a person. The 3 kV isolation creates a physical, non-conductive barrier. It lets the data pass through, but ensures that dangerous voltage cannot. It protects the equipment, and it protects people.
And that robustness seems to carry through to the other specs, too. It works from -4 degrees all the way up to 131 Fahrenheit. Pretty wide range.
It has to be. These things get installed everywhere, from unheated substations to hot factory floors.
And I see the usual alphabet soup of compliance. CE, UL, RoHS, TAA. What does that tell a potential buyer?
It tells them it's safe, it's legal to sell, and it's environmentally responsible. UL and CE are for safety standards. RoHS is critical. It means no hazardous materials. And TAA means it's approved for U.S. government projects. It's basically a checklist of trust.
So this isn't really a standalone tool then. It's clearly designed to be a component, a piece of a much larger system.
Absolutely. The whole point is integration. The fact that it comes with different cables and even its own power supply for connecting to, say, older systems tells you it's built to be modular.
It's built to speak the language of the facility.
Exactly. It doesn't just measure the current. It communicates that measurement in a way that everything else can understand, safely and reliably. And, this brings up a really important question. We spent so much time focused on the power itself, the 2,000 amps being delivered to the machinery.
Right, the energy doing the work.
But how much value is really in these silent tools, these non-invasive transformers that just sit there and watch? They allow you to monitor everything safely without ever interrupting that massive flow of energy, the reliability of that information. That might be the most valuable asset in the whole facility.
A great thought to chew on. The invisible infrastructure that keeps our world powered. Thanks for joining us for this deep dive.